This is an AQA GCSE chemistry question. It's a Trilogy 2019 paper, Foundation Tier, and it's on the Earth's resources. Going to recommend you pause, have a go at the question, working through, and then we'll review. So here's part A, part B, part C, and finally part D, an 8-mark question in total. So let's take a look at part A. How is fresh water obtained from seawater? Arguably, you could say distillation, but it's not there as an option. We actually use the term desalination to remove the salt. The seawater at location X is warmer than the seawater at location Z. Why would the salt concentration at X be higher than the salt concentration at location Z? So we're going to go into wider knowledge of chemistry here. If you have a greater concentration of salt, that would imply more salt in the same volume of water, or the same volume of salt in less water. Well, in X, there's greater evaporation, so we're going to have more of the water evaporating, leaving the salt behind. It also makes sense if you look at the positions that X is close to the equator and Z is way up near the Arctic Circle. On to part C. Location X is in the middle of the ocean. Location Y is near a large city. Why might the seawater near a large city have more dissolved solids than seawater in the middle of the ocean? Not something we necessarily want to think about, but there might be more sewage, there might be more industrial waste there because it's a more built up area. And to finish off part D, we have got students separating the dissolved solids from a sample of seawater. Describe a method to measure the mass of dissolved solids in a 25 cm cubed sample of seawater. Well, we've got an evaporating basin here, we've got a balance, we've got our seawater. We're going to take the mass of the basin alone. And then we're going to add 25 cm cubed of water to that basin. What we can then do is heat to evaporate that water. It's really important that we also think here about heating to dryness. So we can heat, and then once it looks like all the water's gone, we take the mass. And then we heat again, and we take the mass. And then we can heat again, and we can take the mass. And we continue to do that until the mass stops going down, because at that point we can be confident it's heated to dryness and all of the water has gone. Once we've done that, we have got a basin containing the solids, and we can take its mass. We've got its mass. We subtract from that the evaporating basin that we took at the beginning, the mass, and we're left with the mass of dissolved solids. And that takes us to the end of this question.